Hello everyone. Amidst ongoing international conference on climate change, today we are going to discuss about consumption of fossil fuels and generation of power by various types of energy sources along with the emission of carbon gases with respect to the revenue generated from industrial, commercial, and residential sectors across all states in the United States of America. Firstly, we have performed cluster analysis for the integrated data set based on various variables present in the data set. After performing clustering, 51 states are classified into 6 clusters. This map shows the clusters formed for various states with each cluster color-coded. To analyze the characteristics, we have plotted emission of harmful gases with respect to different clusters. In this map we can clearly see that the states coming under Cluster 5 and Cluster 6 are emitting less greenhouse gases. On the other side, Cluster 1 and Cluster 2 are producing more greenhouse gases. We have also plotted per capita revenue, which is the revenue per customer for our clusters. From this visualization, we can see that Cluster 5 has the maximum per capita revenue generated for almost all the sectors. Then, we have plotted the average electricity produced and average fossil fuel consumed for each cluster. In this sheet, we can see Cluster 1 has maximum electricity produced and maximum unit of fossil fuel consumed. Now, we would look onto utilization factor, which tells about the energy generated with respect to the unit of fossil fuel consumed by different states over the years. In this sheet, we have shown the values of the utilization with descending values from highest to lowest, and we have also plotted the trend of utilization factor across the years from 1990 to 2013 for all the states. From this we also see that states having high power utilization values mostly comes under Cluster 5, which produces maximum per capita revenue for almost all the sectors. Now, we would like to compare the states with top 5 high utilization rates with that to states with top 5 low utilization rate. The states with high utilization rate is shown in green trend line with yellow background, and the one with low utilization rate is shown in red trend line with blue background. In this graph, we have used small multiples to compare the emission of CO2 gases with respect to the consumption, and we found an interesting insight that for the lower utilization states, the amount of CO2 generated remains constant for all the years from 1990 to 2013. We then plotted the emission of CO2 gases with respect to 1 unit of electricity generated and found that the emission of CO2 gases for high utilization states are very low when compared to the lower utilization states. The reason why we are analyzing CO2 gases alone will be shown in our next 2 visualizations. Here we are plotting emission of carbon dioxide, sulfur dioxide, and nitrogen oxide per unit fossil fuel consumed across the years from 1990 to 2013 for all states. We can see that over the years metric ton of CO2 gas has a constant trend with a higher scale than the other 2 gases for all states. We also plotted trend of these gases emitted when 1 unit of power is generated over the years from 1990 to 2013 and for all the states. We see that the trend is decreasing for SO2 and for NOx gases and is constantly low when compared to the CO2. Hence we have taken the emission of CO2 for plotting. We then try to analyze why CO2 emissions are higher for lower utilization states. In this visualization we are color coding the type of producer to find what exactly leads to more CO2 emission. We can clearly see that for the lower utilization states, they are predominantly using electric utility as their type of producer, which has relatively larger values when compared to states with high utilization. From this we can infer that extensive use of electric utility is the main reason for the higher emission of CO2. In addition to that, with this side-by-side circle map, cogeneration, one of the type of producer, is the one which is emitting higher CO2 gases for most of the states. Cogeneration produces both energy as well as heat. That might be the reason for emitting more CO2 when compared to other type of producers. We now try to get the relation between the revenue generated from various sectors when 1 metric ton of CO2 gas emitted. From this graph, we can clearly see that geothermal is producing more revenue per CO2 emission, which means that it has generated more revenue with low emission of CO2 gases. In commercial sector alone, other gases produces more revenue per CO2 emission. Thus we can conclude that geothermal source of energy emerged as a winner among generating more revenue with low emission of CO2 gases.